Alright, so begins another draft physics video presentation and such. I'll take care of one comment and then move on to, I think, just a narrative of the last 10 years of my construction of, how the thought process, getting from point A to whatever point this is. And an explanation of why I'm quite confident and blah, 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 blah. So anyway, Abdullah Morosa says, I replied before. Here's the links again. Yeah, the same links I've already talked about and discussed. And so he thinks this is better evidence when it's just plain junk. I mean, it's sort of just an indictment of your whole process, right? I mean, you're just people show up in the argument against evolution and say, well, there's too many missing links. The fossil record is incomplete, blah, 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 blah. That means they couldn't have existed because they weren't fossilized, therefore, and therefore they couldn't have existed. And, the simple counter argument is blah, 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 punctuate equilibrium. Most of the evolution happens in small populations, not big populations, blah, 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 done, solved. And so you're just doing what they do, right? They find a fossil where two bones are the wrong kind of bones and they're in the same place, and then they figure out, oh, a whole bunch of animals were killed in that same location, and that's why the bones aren't right. It's creationist arguments. I mean, there's a simple argument being made. The evidence is insufficient to the veracity of the claim. You're making this claim that you've proven it, you've demonstrated it's beyond any reasonable person's doubting, and the evidence is far deficient, and you just don't even want to admit anything. You just have no credibility as a reasoning person because you won't admit when your evidence stinks. And it stinks. So he posts a link to the amateur guy. I've already pointed out it's an amateur astronomer. He has a way insufficient telescope, 5-inch. Eddington's was 12 and 12 feet long, which is a huge difference because it's a real optical telescope, not a reflector and not all this, gadgetry. So there's a lot less distortion. It's not the same experiment in the sense he didn't even take control pictures. He uses, other abstractions to decide he knows where the position is, star charts and such. It's just completely insufficient. It's not a superior experiment. It's not using superior technology. It's using far inferior, a digital camera that's far below what's necessary. I mean, they're time-lapse photos that can't have any, noise in them. And obviously digital cameras, they can fool us kind of easily. So they make up a lot of the pixels, out of averaging. So it's not even a real image. I mean, it's pathetic to argue that that's good enough. That's just as good. We've done it. It's not the same experiment in any way, really. I mean, except in the idea you're pointing something at, attempting to point it at an object. Beyond that, it's nothing like it. You still haven't answered my simple point. With all our technology, why haven't we done it from space? The ideal place to do it from. And then this interferometer thing, radio interferometry, is pointing two different radio telescopes at a location, take observations over a number of days. I mean, did you read the article? I mean, the complexity of what they're relying on is insane. They're not getting any image. They're just changing. All they're measuring is a phase difference between the two telescopes, which I don't know exactly how that can tell them the exactness of the position. But regardless, terrible experiment. I mean, there's no way to isolate out scatter as an explanation. As I pointed out, scatter goes everywhere. So you can find the shortest path, you can find the longest path, you can find all those colors of the rainbow, so to speak, in the image. If you want to find, it's like looking at light from a prism and saying, I want to see the blue light, well, I just move over here. I want to see the red light, well, I just move over here. I mean, this isn't credible, high integrity evidence. And you just, I'm so, what's a reasonable person supposed to say? I mean, this looks desperate. You're saying you've proven something when your proof is far, far below the standard it should be for the claim you're making. It seems like it's a pretty simple claim, and yet you don't have any data to prove it. And then again, even with the sun, the gravity lens is the wrong shape. I mean, you still haven't even answered the question of how you can magnify an object at great distance with a lens that's the exact opposite shape, that's bending the light that needs to be bent more less, and bending the light that needs to be bent less more. It can't work. You can't see a whole image because the light from one side of the image needs to be bent more and you're bending it less, and the light from the other side of the image needs to the exact opposite. So what sense does it even make as a theory? How do you even get past the theoretical arguments of the impossibility of your imaging, quote unquote, with gravity, when again it's the wrong shape lens? So don't answer my simple questions. Instead, just keep throwing crap I've already responded to numerous times and pretend you've made some brilliant argument. It's not a brilliant argument, and your exaggerations and your hyperbole and your inability to admit simple truths that no, the evidence isn't as good as it should be. If we're going to make assertions, if we're going to tell reasonable people they have to believe, we should have a Darwin book. I mean, we should compile the evidence first and present the evidence, in the right order and structure, and concede that this conclusion was jumped to way too soon. The Eddington experiment was bad. I mean, it wasn't just bad theoretically difficult. It was bad in the sense that both of the teams that went out to get images had horrible physical problems getting the data. They were 10% the experiment they were hoping for. Eddington was hoping for 10,000 stars. Yes, 10,000 stars on his photographic plate. Compare that to the amateur who was hoping to get 100. I mean, and he only got 1,000, Eddington. 10% of what he was hoping for in terms of the quality of the images. And so again, just instead of admitting the simple truth that this was a conclusion jumped to on really pretty bad evidence, a pretty bad experiment, and you've decided to declare it a truth based on that bad evidence, and you don't want to let go of it. And you haven't been able to confirm it with the best technology. You just keep saying, GR's been proven 1,000,000 times, blah, 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 blah. And again, you don't deal with the real subject or the real issues, which are, this isn't about time dilation. This isn't about all this other crap of GR. It's about one assertion. Photons are bent by gravity. And the simple argument that you can't prove it, okay, by sending light through a medium and watching the light scatter. That's not going to prove it. Anyway. So, whatever. I don't know what to say. I mean, you obviously don't want to engage in any kind of, meaningful way. First, even if you didn't know, I've already argued these two experiments already. Even if you didn't know that, the fact that you're presenting them again, two completely flawed pieces of data, and you're claiming their proof. I mean, even this one's, it's 1995. Okay, so in the intervening 25 years, you haven't got better evidence than this? I mean, you're proving my point for me. You have no interest in in persuading me with reason. You just wish to persuade me with propaganda, and meaningless mush. Again, the creationist with his, look, there's a fossil with a human footprint in it. A dinosaur foot with a human footprint. That's all you got. And you just keep shoving it in everybody's face like that's real evidence of anything. When already it can be explained rationally. But forget about that. We don't want to do reasoning. All right. Screw you. So I guess I'll just put the website up and use it at my leisure. Maybe we'll dull it down a little. Yeah, maybe. Yeah, what the hell. and I'll draw. All right, so this all started really with the fact that I was very uncomfortable as a kid when I heard this idea of a photon being a wave in two fields. Okay, I mean, it just made no sense to me, this idea that we have these two magical places where some sort of magical thing happens, and you have this magnetic component and this electric component doing some kind of thing. These fields were going making some sort of whatever that was. And to me, logically, refraction and diffraction and all that stuff, it looked a lot like this is just stuff bouncing off something. I mean, especially reflections. They just look so much like, something would bounce off of. What do you think it's going to do? The energy goes in, the energy's got to come out. So, of course, this would be equal, and, angle of incidence equals angle of exit and all that kind of stuff made perfect sense to me, and it made perfect sense that this is a real piece of momentum and it really does bang around in things. And this isn't about any wave. And if there was a wave, it seemed like radio antennas, it seemed kind of obvious that the radio antenna was creating a wave in the sense that there was a antenna and there was stuff vibrating. You put in kind of mediocre frequencies. We provide the frequency. Okay, unlike light, we can't make an electronics that's going to vibrate fast enough to create light, but we can make a frequency. We can just dial in any frequency we want, and the frequency is just saying this thing's vibrating, and it's going to create these, what you could call them waves, but we know the wave is made of something. Okay, these are soldiers, and you're sending them in a set pattern based on the vibration of the antenna. Now, what I've added to that is the idea that what decides how much antenna you need is really the speed of light, because the force can only get so far up the antenna in the amount of distance it has to create the next wave. So it can't create the waves, microwaves can't get far enough up the antenna. They can't use this whole, I can make a big giant antenna, but it won't do me any good, because the frequency is dictated essentially by the time it takes to get to this point to be able to send a guy out before the next guy has to be sent out. The only way it can work is that the antenna is time dependent. And that made antennas make more sense when I added that bit, but that was much later. Alright, so it started with the idea, this was my vision. Photons had to be something real. They weren't, if you wanted to believe in an ether, fine, in the sense that it was stuff banging into stuff, banging into stuff, banging into stuff. I mean, I sort of said that was okay, but again, that logically didn't make any sense to me, in the sense that you can't organize this stuff in any kind of way that allows you to have any. It's the checkerboard problem. The diagonals are going to have stuff further away from each other. The distances aren't going to be consistent. You can't have something that can leave at any vector if you have a checkerboard. It makes it impossible for certain angles to work, and it didn't seem like there was any of those limitations in the natural reality. So ether just didn't, it didn't appeal to me for because it didn't seem to serve any purpose. It's, why have a bunch of dominoes when I can just, that I move, when I can just move the domino. Why waste my time moving all these dominoes when I can just throw the domino to over there and move this domino? Why waste time with the dominoes? So, and thinking about light, and then the proposition of gravity. So I had a kind of idea that this force stuff, this invisible stuff, radio waves, all this stuff, is just as invisible as gravity, but it can have just as real an impact if you focus enough of it. In a clear atmosphere, you don't see a laser beam, but you can have a really strong one and you can hit something and it doesn't even know it got hit. So I mean, the idea of force being conveyed from one thing to another in invisible ways seemed completely, yes, that can happen. So I started thinking about gravity, and I had no knowledge of Lesage's theory from 200 and plus years ago, or Fadio, the guy 300 years ago who thought of this, which seems quite brilliant on his part, actually. In considering that everybody believed the Earth, most people thought the Earth was flat, and well, a lot of people, and God done it and all that kind of crap. It seemed quite clever. So the idea would be is there is this force in the universe, and it irritates everything constantly in all directions. And as I've pointed out, if you create such a field, as indicated in the website, from any location, it's going to be pressure in all directions. So if anything in any location is going to say, it's all heading right for me. Anything that hits me, okay, is I'm just going to feel like I'm the center of something, and there's a ton of stuff coming right for me. And the idea would be as if you had that scenario, a world where you have some, let's just say it's a quarter, a round quarter, let's just say a little steel ball, and you had a bazillion BBs, the little tiny balls, and you had a box of some kind that was perfect in terms of perfect rubber, super ball kind of surfaces, and so the BBs would always bounce back with the same momentum. They never lose any momentum, and they just bounce around inside the box. That would be the idea, and that if you put two things in that box, what would happen to them? Some of the BBs would obviously hit from certain angles. They could make it this way, and they could make it this way, because they all travel straight line paths. But there would be this problem that between them, okay, there really isn't any BBs. And so there's going to be pressure that's going to be building up on these outside surfaces, saying go that way, hitting them, and there's not going to be any between them, and so the two objects are going to end up going towards each other. And so that's the basic theory, and it basically does happen in reality. It's called mock gravity, and now instead of Lesage or Fadio, as they apparently don't want to give credit to where credit's due, and as a theory, it works. It theoretically functions to cause the basic function of gravity, which is attraction, and to do it with an R squared rule. So it comes out mathematically to be quite correct. And then the argument is that there has a couple of these flaws. So anyway, it's exactly what I thought of, is what happens if you think about this as particles, and I deduced that you would create gravity and that it would be an R squared rule and the whole thing. So that was also my deduction. And then I was confronted by people who brought up the fact that, it has these proven flaws, and one of them is that in a system, in a field where you're traveling through the field, so if you have a field of bits all moving in some direction, and then you move through that field, the problem is you're going to hit more stuff going against you, okay, just as a law of probability, than stuff pushing you. So in such a field, you're going to have, I should put less of those, because less of those will get to you. So you'll encounter more things coming against you than things going with you, and therefore you'll be dragged to a halt. I think that's correct. You'll stop going in the direction, you'll slow down little by little, because you're going to crash into more stuff, more BBs coming against you than BBs that are going with you, just by laws of averages. And the faster you're going, the more that's going to be a problem. So it's a real subject. And then the other problem is this time delay problem with gravity, that if two bodies are creating gravity, the one body is going to be sending the signals at the speed of light, and so if it takes any time at all for the lack of pressure to get to one object and then send the signal back that, hey, I got no pressure here, so I'll send the signal back. Well, the problem is it'll send the signal back to a location where the object isn't. So the low pressure will be here, and the object's over here now. And so that ain't going to work. And so you have to understand that there's a little subtlety to the process of gravity, in the sense that just like the process of heat, if I'm going to heat something up, I pump energy in, and the truth is the energy doesn't go out. It stays in there. And that's when something's getting hot. That's like acceleration. You're changing and moving, and that process absorbs energy, where the process of, once you reach a temperature, say you're 78 degrees, now everything that goes in, because you're not getting any hotter, you're staying 78, everything that goes in comes out. So you're at equilibrium. And that's a whole different kind of idea. But the idea is, as you know for sure, that energy did go in and it didn't get out. And what is energy? Energy is just movement. So the key thing to understand is that the Earth, inside of it, is moving. Okay, it's got a bunch of heat in it. And heat is this energy. Heat is this stuff, quantized. This is just quantums of energy. Light, even, is a quanta of heat. And the fact is the Earth has stuff going this way, and it has stuff going this way, and it has stuff going this way, and it has stuff going this way. It has stuff swirling around in its core, constantly moving. So it has a ton of motion trapped inside of it. You know, stuff moving. And it's the important fact is the stuff being absorbed, say this is going to move this, you know, keep it going. It can't just perpetually go. So that's sort of the drag argument again too, but it can't just perpetually go. It has to be constantly fed. And so the stuff moving this way moves because it absorbs some energy going this way. And to keep this stuff going this way, it has to absorb energy going this way for a period of time. And that's all you need it to do, is for a period of time. But anyway, and the trick is that if I'm sitting over here, I don't see this getting absorbed, because that already went past me. That's going away from me. It's affecting something else. I won't be affected by it. But this, I am affected by. This absorption means I'm not going to get hit with something. Something moving the speed of light was heading right for me. It's instead going to go in here and swirl some stuff. It's not going to get to me. And that's going to create the lack of pressure in this direction. I'm going to get hit by less of this speed of light stuff, because it's stuck in here going less than the speed of light. And therefore I'm going to have more stuff hitting me from this direction than from this direction. And that's just because this motion has to be constantly fed. All right. And the only part of the feeding I don't see the part that equalizes it, that leaves going this way. I only see the part that is absorbed going this way. Just like somebody on this side of the Earth only sees the exact opposite, right? Or this side, if this was the Earth, this guy only sees, you know, what the stuff going this way is absorbing. It doesn't see the stuff that is going to be relevant to it. So the stuff that's affecting me, the absorption that's affecting me, is exactly the opposite to the absorption that's affecting him. And that's what maintains the system. So that takes care of the aberration argument, in the sense that the gravity isn't. It's also, well, I really don't want to get at just exclusive subjects. I want to do more of a generalization. But I mean, it's physics. You do need to account for all the aspects. And the real point is that when there's an absorption in this direction, it really means an absorption in all of the forward directions. So when something absorbs energy to balance, it absorbs it. It can absorb a piece going this way. It can absorb a piece going this way. This way. They all have a component in the direction. So any component in the right direction counts as part of the gravity. So you have to think of the gravity you're causing, that is by absorbing energy, motion, by moving. You have to absorb energy to move. You move to a new location. You absorbed energy to do that. Energy didn't hit here. All right. And the effect, the loss of momentum, will be felt in the sense that there will be less energy. So just think of these arrows as being decreases in energy getting out, will affect the entire 180 degrees of the sphere on that side. And so it comes out in all these locations. So that's why it doesn't matter whether the Earth is here or here or here. At all those locations is exactly the same gravity. And that's just like the charge argument. Charge works the same way. Charge is point source, and it's in all directions exactly the equal amount from the equal distance. So as long as I'm an equidistant from some object, there's always an absorption in that direction. And so there's always gravity there for me to fall into. So the gravity you fall into isn't the gravity you're making. It's the gravity the object is making by consuming energy in the form of moving. Being moved. Being moved requires the absorption of energy. So anyway, so that's enough for gravity. So I'm just saying this mechanical model works for gravity. It explains it. It accounts for the process, and you can account for the limitations. Now the drag argument's a little more complicated. I just get to the simple wagon idea. You throw energy in a perfect system where the energy can be trapped and it's no friction. You could understand that the thing is going to bounce back and forth, and those are all going to be equalizing. There's going to be energy this way, and then there's going to be energy this way, and then there's going to be energy, and that's all equals out. But the fact is, you never undo the first motion. So the first motion ends up giving the whole wagon motion in this direction, plus, and then when the reflection takes place and it hits this back surface, well, you go to zero again. And then when it hits the front surface again, it goes back to +1. And then when it goes back, it goes to 0, and then it goes to plus. So you're never, you're not going from that direction to that direction. You're just going from this direction to stop, and then this direction, stop, this direction, stop. So the thing just keeps moving. It goes to 0, then it goes, and then it goes to 0, and then it goes, and then it goes to 0. And such a device, if I could make one out of electrons and protons, and the helium nucleus is what they claim to be the smallest object, theoretically, that you can shoot out of a gun and keep it moving. Something you could shoot into space and it'll just keep going. We can't shoot protons to the moon, we can't shoot electrons to the moon, but we can shoot helium nuclei to the moon if we chose to, because they can keep going. So they can keep doing this. They can make the wagon and keep going. All right. Theoretically. Anyway, that solves the drag problem. So these weren't overcomable. These weren't overcomable obstacles, flaws in the rudimentary theory. But in Newton's time, yeah, they were flaws that seemed insurmountable because they didn't really understand the force. They didn't know what was causing it. And so when something like this simple R drag argument comes up, it's like, well, what's the explanation? And they couldn't make up one, so they were stuck. But there is an explanation. You can find a mechanism that does work. And they just didn't look for it hard enough, or well enough, or whatever you want to say. So anyway, so then this applied to you going. So once I got gravity, you know, I was happy just having the gravity argument. I would have just settled for that. Okay, gravity is a particle. You can fix Mach gravity, and it's a good explanation. But then I started thinking about magnetism, and thinking, well, it's the same force going on here, right? We know, okay, that it's the same thing. I mean, the same charge looks just like gravity in some senses, in the sense that it has the attraction component. And so I don't know which one I thought of first. The idea of charge. I mean, I could just write this as, you know, plus. Do it backwards, Gary. Minus plus. And the fact that it does have the inverse square law, the same kind of things seem to be in play. But the repulsion thing seemed strange. Why do two things that are the same, why do they repel? I mean, how is there more pressure stuck between them? You know, that was a tricky one. And like I said, in the same way I was thinking about magnetism, it behaves much like charge. If I was thought of it as, you put two charges next to each other, you really have the first magnet. In the sense it'll behave in the same way. Theoretically, there's no real difference. And so atoms are magnets in a sense when you're lopsided, and are from a distance. But anyway, so then I had to try to think of, and I thought of different swirly things and swirly theories of things spinning, and maybe this one's spinning this way and that one's spinning that way, and gears like Faraday. I didn't know Faraday had a gear theory, but I was definitely thinking in terms of gears in the sense of motion this way and motion this way, and if I put another little thing going in here the other way, then these two will mesh. And so, I mean, you're trying different ways to make the mechanics work and to figure out, but you can't think of it. It doesn't come up with anything that does anything really substantial in terms of creating repulsion, strong repulsion. And so then I thought of ping pong paddles and a ball bouncing back and forth. And the fact is that if I could trap energy, I thought about trapping, probably can't see that, but oh yeah, you can. What would happen if I trapped a piece of energy and the energy was perpetual, like photons can never die kind of thing? Well, where do they go? What do they do? So I thought about that a circle is really just right-hand turns, right? You just 4 turns, and you just keep doing those 4 turns, and then something that was going the speed of light and it was getting somewhere is now stuck going nowhere. It's still moving, it's still going the speed of light, and if I release it, it's a photon or a piece of energy, because that fits in the Einstein way of saying you can't give photons more motion, you can't give them 2 momentums. You're really just releasing something that was already going the speed of light, you're just giving it back. And that's the sensible way to view it. I said, well, that's all very logical. So yeah, if I make a trap, so then I thought about different kinds of traps. And first they were circular traps, because there's a lot of circles in the world, and the idea of the processing circle, going through space, you can sort of get that, but giving it more thought, I realized, well, the simplest trap is just the 2 paddles. Just trap it going back and forth. And what would the consequence of that be? And then that's what I thought of. Well, whatever energy goes in first is always going to be there. You're always redoing it. You undo it by going backwards, and then you redo it by going forward. And then you undo it, and then you redo it. And you undo it, and you redo it. And that there is no equilibrium here, in the sense that there's no balance between this way and that way. The real balance is this way and no way, this way and no way. So once you sort of realize it's 0 and 1, it's not -1 plus 1. So the difference is the fact that it has an initial momentum means that you're going plus to 0, not plus to negative. And so that was an important realization. And so somewhere in there I realized that the only way I can make that ping pong paddle thing is I have to make this possible for this force to get stuck between these two. And then I have to make it possible for when they're going to a proton, they're not reflecting anymore. So they reflect back and forth between the electron, but somehow they don't reflect when they get to the proton. So at first I thought of them just going straight through, which might actually be sort of the right answer. Okay, so this is always getting improved, but it's an ironic part of this is that for the first 10 years of this project, I'm sort of doing everything in 2 dimensions, because you can easily draw 2 dimensions. But the fact is the third dimension does exist, and the fact is that so you could theoretically, if I had something, and let's pretend up is the third dimension, I don't have to just go left or right. I could go up, and if I did go this way, which takes no more effort, you can go left or right, Going up theoretically in space doesn't mean anything, or going down. It's the same as going left and right. But if I did go into this third dimension, I could theoretically come back out of that third dimension and end up going this way or this way. And I'd end up with the same thing as if the energy came in this way. I could have it leave this way, but it leaves this way after it goes into the third dimension and comes back again and then leaves this way. So I can have this almost seem like it's transparent, but it really wasn't. It went into the third dimension and then it came back out of the third dimension, and because it's going in the opposite direction, it takes the opposite path. It doesn't go back the way it came, it goes forward to the way it came. So it leaves, okay, in the same direction that it came because it's getting inverted by going into the third dimension. So anyway, so it can give you the illusion of transparency. It really wasn't transparent. There really was a process. But the fact is what goes in is just going to come out the other side in the end when it's done doing its little gimmick. But the point is that does explain, it does give you the absence of force, because now you have one thing, okay, where one force reflects and then the other force, the other force, if this was a proton and this was an electron, the other force, okay, if it's coming out of the electron, would leave the proton in some direction, okay, that's not back, that's not a reflection, it won't reflect it, all right. And likewise, this other force coming from the proton would do the same thing in the electron. It would leave, third dimension, come back out this way, or perpendicular. And the point is it won't come back as a reflection. So then you get no reflections in here. And therefore you have no pressure pushing them apart. There's no access. There's no energy that goes back towards the objects, and without that energy, without anything trapped between them, the external pressure that they're still being bombarded with will push them together. So it's solved that problem in terms of a mechanism. So it was sort of thinking through it. I can't still say with any confidence or great confidence there's no possible way to make any other theory of a single force that creates the two inverse reactions. So we know there's two inverse reactions, that the same field pushes this away and it pushes this towards. And I've tried lots of ways to think about how one force could do that. I mean, one type of energy. But it really just doesn't work. You really need to have two forces to have the opposite effects on each other. So when a positive piece of force energy, interacts with the negative bit, it does something perpendicular. And when a positive interacts with a positive, it just does this pure reflection thing. This absorbs motion this way, this reflects, and you move the object and you release the opposite force. You make an exchange, essentially. You give it something this way and you take away from it something this way. You end up with a 2x difference in the net momentum of the object. And that's how things are moved in space. That's how atoms are moved, is by a real force. And so even with the two forces, gravity would be exactly the same, because there's gravity is not affecting charges. It's not affecting electrons and protons in any that have any polarity. So the key thing is the Earth is full of a bunch of magnets, you could argue. But the problem is they're all in different configurations. They're all pointing in different directions. And so their profile in net, if this was blue and red, if you could understand the poles as being two different colors, they're going in all different directions. And if I mix blue and red, it's just saying purple. Okay? And the force coming in is purple. It's blue and red mixture. So there's no polarity, and therefore the only effect you can have is to actually absorb the momentum. Whether it's red or blue, it doesn't matter what color it is, you're just absorbing a piece of force. And because the magnets are all mixed up, it just can't matter because there's no polarity. So adding the two forces to create charge, our mechanism that will allow you to have repulsion and attraction, didn't in any way destroy the gravity theory, because essentially, as much as it looks like the same thing, the attraction of gravity looks like the attraction of charge, it's completely different. And that's why one is called a weak force and one is called a strong force. It's because they're not really it's the same thing in terms of it's always momentum being absorbed or deflected. So in that sense, it's functioning the same way in terms of your exchanging movement. Oh, here's the chalk in my hand. But they're distinctly different in that when you have charges, you have segregated the force. And one radiates, just the one force, reflects. And one reflects just the other force. And again, if they interact with each other, the trick will be is that any force from this object will end up doing this, and that will be noticeable. The fact that there's this perpendicular change. See, but if I put them in empty space, this will radiate red and blue. Okay, so if the electron's all by itself, it's going to radiate red and blue. But the trick is the blue stuff isn't reflecting back straight. It's going this way, or in or out. All right, so it's changed its real direction, and that change in direction will be seen once you put another object in its vicinity, because the two will behave in exactly an inverse manner, in the sense that this energy will leave perpendicularly, not back, not reflect back, and the blue going into the other object likewise will go perpendicular. It won't reflect back. So that's the key difference. So if there's only one charge in the universe and it was all an isolated universe, all you'd see is purple. You'd see the red and the blue mixed, and that's all it would look like. But as soon as you bring another object, the purple starts to change, and one side becomes much bluer, and the other side is going to, and then you'll get, whoops, sorry, and you'll get redder coming out of here, and a little more red coming out of in and out, and then it'll go blue on the other side again. So you'll start to make things look polar. You'll see their polarity, okay, as you start having more than one object interacting. So that gets to the basic of a magnet. I guess I'll just cover electricity briefly. See, all the forces that we interact with have to be understood. So so part of this goes back to how an atom is built, and the atom has the positive energy, the protons in the middle, and the electrons on the outside. Now, I would argue they're magnetically held in place by charge, and so they're not moving, they're not spinning around, they're not doing figure eights, they're not doing any of that crap. They're in pretty set positions like magnets. And the pressure between the electrons is repulsive, and their pressure towards the proton is attractive because of the low pressure. So there's low pressure here, and there's high pressure here. I don't know how to draw that differently. How to get an indication of I'll just leave it like that. So it's low pressure here. The white is indicating low pressure, and say the blue is indicating high pressure. So the electrons can't move into the low pressure, because to move into the low pressure, they have to move against the high pressure with the other electrons. So once you have an arrangement, the electron doesn't have any choice but to stay in its position, and that's why these atoms become durable. So you can do geometry here where you can start complicating the geometry. These electrons would be repulsive, and these electrons would be repulsive. So you can start adding electrons to create more and more sophisticated geometries, and those are the 100 elements. So anyway, the forces that are creating motion in the universe are ones that are hitting the electrons. So light is the electron force. You can't make a photon out of the proton force. You can only make a photon out of the energy that moves the electrons, because moving the electrons are creating light. It's the reflections off of electrons. And likewise, electricity is doing the same thing. Electricity is pushing electrons, into each other, moving them into a position and then moving them to a new position. So they're in a new position, creating new pressures between each other, and then that pressure cascades from atom to atom to atom to atom, and that's the movement of the current through a wire. Is just the idea that you're pushing on electrons and pushing them through the conductor, and the more electrons you push on, the more imbalanced the atoms get, right? If I move this electron to a new position, I've changed the balance of the atom. I've probably caused all the electrons to move out a little bit, and I start to polarize the atom, and so then they become little magnets. And so if I have a lot of amperage, that is, I affect a lot of atoms by pushing a lot of electrons, just a little bit, but I move a bunch of electrons, and I push a lot of these atoms and deform their shape, I polarize them, which turns them into magnets, and that creates your magnetic field. All right. So without going into too much detail of electricity, that's why there's a relationship between electricity and magnetism, is that magnetism is just creating polar atoms. That is, changing the relationship between the protons and the electrons to make it so from certain positions, this electron is too close, this looks positive because I can see more of the proton from over here, and because this one's further away, it'll look negative from over here because I'm seeing more electron and less proton. And that's basically all a magnet is. So finally, we'll get to the magnet-ish subject. Probably could scroll down here. To this image. The text in here isn't entirely correct. It's close, but not quite. Well, there's a lot of it I gotta fix. Anyway, we'll brighten that up. Alright, so there you see the basic drawing. So magnets aren't generating any energy. So a lot of people think magnets, conventional physics plays this silly game where they think that because something lines up with the magnet, that is, if I put an external magnet out here, it'll line up exactly inverse, all right, to the magnetic field, because it's going to be attracted in to the blue side will be attracted to the pink side because of the low pressure, and so it'll line up. So a bunch of magnets line up going around the magnet, and they think, because of a mistake by Faraday, that these lines have a direction, and that there's a stuff that's actually going from one end of the magnet through these lines into the other end of the magnet. And that's a synthetic image. It's not the real function. So the real function of the magnet is that it's creating pink energy up on this end, and it's creating blue reflections, if you can understand them as reflections, here. So anything pink that goes into this side does the perpendicular, anything blue, pink does reflections, so any pink energy that hits just reflects back out, and any blue thing that hits does the perpendicular thing, ends up coming out the blue. So this one's doing all blue, right? You can sort of understand that, and this one's doing all pink. So that's why magnets are so incredibly strong, is because they're really segregating the force. They're really making a huge difference. They're taking the purple out and making very strong blue and very strong pink. And when you put a whole bunch of them, stack them on top of each other, you could sort of understand that if, this is another blue magnet over here, the blue end, and it's the pink end up here, because they have to stack by staggering with each other. right? Then you could sort of understand that anything pink that goes into this blue end comes out this, whoops, that's not the right color. So anything pink that goes into here comes out this end pink. So you can see how the magnetism will just keep traveling out, and you'll keep getting pink coming out of pink, and you'll keep getting blue coming out of blue. And so it's maximizing that. So it doesn't do anything. It just takes what the field throws at it, which is, the field is constantly pushing in red and blue, as the drawing shows. And the magnet is just filtering it. It's just converting that mixed field, purple, and it's saying purple is made of red and it's made of blue. And it's segregating it. And that segregation is incredibly important, because if I put an electron here, he says, hell, this is a shitty place to be. It's completely reflexive force. Complete reflections happen back and forth. The electron says, I'm getting out of here. I put an electron up here, though. It does exactly the opposite, because it's all weak force to him. Doesn't mean anything, and he goes right into it. And vice versa for the proton. But there's nothing going around the magnet. And the reason why these lines are spaced is because these iron filings, right, or even if you did it with compass needles, they line up exactly the opposite of the original magnet. So if I took 1,000 little compass needles, broke them out of the compass, and I just threw them, they'd just be the same as iron filings then, and they'll all line up exactly the opposite to the original magnet. So all of these magnetized strips now are becoming magnets. So this whole line of iron, okay, oops, wrong color. This whole line of iron filings is itself becoming an opposite magnet, right? I don't know if you can see. Well, I dropped the chalk again, so hell with it. Really can't see that. So this is becoming, let's say, a north end, and this is a south end. And the magnet's north and south. And each one of these is going to be the same as the one that's being created. So this one's going to be south. And this one's going to be north. And so you can obviously kind of understand why there's a gap between them. They're repelling each other. So that's why the iron filings don't just point this way, into the thing, and that's all you see. Like if you do the head of the magnet down, if I put the north side of the magnet down, that's what I'll get. It's just spirals, but radials. But the point is the reason why the dipole field ends up with this separation in it is because these two magnets are going to repel each other, because of the same exact magnetic field that they're creating. So that's why there's lines between the iron filings. But these aren't pathways for anything. These are magnets. Nothing's moving through them, from a north end to a south end. Nothing's coming out of the magnet, going in this way and coming down this way and coming out this way. None of that's happening. All of these things are just radiating, reflecting the world they hit and the world that gets to them. And that's all that's happening. And these have bits caught between them. They're pushing them apart because it's reflective inside there. There's stuff caught in between, and that explains coils and the fact that you put metal inside, it reflects off the metal because the metal becomes magnetized. So anyway, it's all there. So anyway, that's the process, step by step, and it fits and it works. And like I said, 300 years ago they had a chance to get it right, and instead they chose badly. And the bad choice of going with wave theories and then randomness theories and just wrong ether theories. And that's essentially what big physics is an ether theory. That's why they don't explain the fields. They just say electric field and magnetic field. What are they? If they're permanent fields. See, I'm saying there is an electric field, or a charged field you could call it. There's one field of this red and blue stuff, and that's it. Okay, so it's one field. It has two elements in it, but it's one kind of field. And that's even part of why this is sort of should be inducive to you, is the sense that, yeah, you could sort of understand that they've replaced the two segregated fields, that is the electron force from the proton force, and instead they're calling them two different fields because there is two different subtle effects. But there really is no magnetic field and electric field. There's just charge. And when you smash two charges together, you create dipoles. And then you have dipole fields, purple fields again. And that's it. It's not that complicated. But there's no electric field. Electricity is a thing that happens between atoms, sharing electron pressure from one atom to another atom. That's electricity. There's no electricity without atoms. All right. So that's everything else is magnetism. And instead, they chose badly. They chose an electric universe, electric monopoles, when if you understand what charge is a magnetic function. You shove two charges together, again, it will behave just like a magnet. If I shove two charges right next to each other and two charges right next to each other and force them to stick, I'll have two magnets. They'll switch, they'll flip, they'll do all the things two magnets do. They're two magnets. They're not electrical. They're magnetic. But again, the magnetism is made out of charge. It's made out of the fact that there's two forces, and there's two kinds of matter, electron and proton, and there's two kinds of interaction, reflection and diversion. And that's it. So anyway, it's a reasonable explanation. It fits the evidence. It explains the existence of the fields. It explains the phenomenon of repulsion and attraction and why it's there. It does the job, and it completes the picture quite reasonably. And any counter argument should be made of some explanation for how it doesn't. Because it does. It does fit the evidence, and it's really simple, and it's really mechanical, and it's easy to draw. And yet you're saying your abstract theory full of randomness and woo and virtual photons and bent geodesics and all that mush is somehow necessary. Well, demonstrate its necessity, because this simple thing answers the questions. It's the best I can do, I think. Well, won't say that. It's the best I did today. So we'll see. So till the next time and such, I can only reason with you. And again, if all you're going to do is propagandize and keep asserting it's the most proven theory in the history of mankind, we've proven everything. We got a ton of evidence. No, you really don't. Not good evidence. And you don't have any answers to the simple questions. Is there really such a thing as a beam splitter? I mean, the idea of taking a beam of light and splitting it into equal beams? Identical beams? Can you do that with a half-silvered mirror? When you know the half-silvered mirror has a bunch of holes in it, and you know that when you put light through a hole, it bends? Come on. Yeah, well, you're just unreasonable, so I shouldn't. What's the point? That's all I can say is what's the point, because you don't want to be reasonable. You're religious kooks, you're fanatics, it just doesn't matter, evidence, you don't care. You've called yourself the science religion, and therefore you have some integrity. Your religion is better. But you're just like Christians, just saying to some foreigner, do you believe in this book? And if you don't, I'm going to kill you. That's all you're doing. Okay. So, till the next time and such.